All right, guys, so today we're moving to the next to the last section in this particular chapter on inequalities. I know it's been pretty quick, but there's only 5 sections or so in this chapter, so this shouldn't be any more difficult than what you've already been doing, even though it is called compound inequalities. It just means you've got more than one, really. But we're going to be talking about 2 different sets here, and you notice I've already got 2 different problems here that we're looking at. And so you're going to find out that you're either going to be talking about and or inequalities, okay? So these first 2 that we're going to look at, the task here would actually be just to graph these, okay? So I'm going to go ahead and start with a number line, and you're going to see real quickly what happens here. So I'm going to go ahead, we'll put -1 over here. We'll start with 0, 1, 2, 3, and 4. And that way we've got every value represented that we need to do. Now we could just put the 1 and the 4, but just so we can kind of see what's going on, we could go ahead and put all of them. You won't have to put any of them because you're just going to have to choose the right answer choice on this form that you're going to be working on. But so in this case, remember that we have just the less than symbol here. So the first statement we have is x is less than 1. And I can use this symbol so long as I keep this variable on the left-hand side. So I can literally use this to help me graph this. Now remember from graphing inequalities, I think it was section 1 of this chapter, that we discussed the fact that if there's no line underneath here, then that means it needs to be an open circle because it's not really including 1. It's everything less than 1. So what we would do is go to the 1 and go ahead and put in open circle, just like that. And so I'm not including 1, but I want everything less than 1. So again, this symbol tells me which way I'm going to shade. So I would shade everything that's this way. And I know that's probably hard to see with a pencil, but you kind of get the idea there, right? And then I would also go to, it says x is greater than 4. Again, I don't have a line there. So I'm going to go ahead and put an open circle there in that particular position as well. And it says everything greater than 4. So that means I'm going to go to the right. Again, this symbol, as long as I have the variable on this side, this symbol will tell me which way to go. So I know that I need to shade this way. So you'll notice with an or inequality, notice we had this was part of our question. When we have an or inequality, that the direction is in opposite directions. It goes infinitely in the opposite directions. And so 1 would not be a part of our solution, 2, 3, or 4. None of those numbers would be a part of our solution. Now, any number this way would be a solution, and any number this way would be a solution. So when we're talking about or, this is the way our graphs are going to look, okay? Now, another notation that you're going to see, and this probably looks kind of different than anything maybe you've seen before, is like in number 2. And so you're given something like this where you have the x value that is kind of in between these 2 quantities. And so it's like, what in the world do I do with this? Well, what I want you to realize is really there's 2 parts to this, okay? And this is the reason it's called compound inequalities. And this is a more familiar notation. And this one you're going to discover is actually an and inequality, okay? So what I want to show you is we can look at this as 2 different inequalities, all right? So first, what I'm going to do, I'm just going to cover up this part right here so that you don't see it. So all we're looking at is this left-hand quantity that's over here. So let's go ahead and write down this one kind of as a separate inequality. So we have 0 is less than or equal to x. Again, I'm not even worried about this portion over here at this point. Now let's do the same thing. Let's cover up this portion, and let's just look at this. So this is my other inequality. I have x is less than or equal to 3. Now, what I want you to notice is the way I wrote these down, I just basically just kind of neglected one side or the other. What I want you to notice is here in this one, I do not have my variable on the left-hand side, which means I could not really use this to graph at this point, or I'm probably going to make a mistake. You could graph it, but you're probably going to end up making a mistake here. So one of the first things we need to do is we need to move this variable over to the left-hand side. So in order to do that, remember, I can switch those 2 quantities around. I can put x over here, and I could put 0 over here. The only difference is I have to switch this inequality sign. So now I really have x is greater than or equal to 0, and x is less than or equal to 3. So let's graph that. And I don't want you to get that this graph confused with this one. This is the next problem, okay? So we're working on number 2 right now. So I'm going to go ahead and just put in a -1 just so we know where that's at. 0, 1, 2, 3. So there we have it, okay? So first things first, it says x is greater than or equal to 0. Well, we notice there's a line underneath here. So that means this is going to be a solid dot, right? A solid point, just like we did in 3.1. Now, if you notice, I'm supposed to be shading to the right of that. So I'm going to go ahead and just shade just a little bit to the right, okay? Now, because this is an and inequality, it has to meet both conditions, okay? So now let's look at this other one. We have x is less than or equal to 3. So again, I'm going to come over here to the closed, put a closed point, and I'm supposed to be shading to the left. Well, I can shade to the left, but all of a sudden I'm going to hit the 0 that I started with. And if I shade to the right of 0, I'm going to hit the 3 that I started with. So an and inequality looks like this when you graph it, okay? So you're literally going to have a closed portion, almost like a segment, that does not extend in both directions. It is just through one particular section, okay? So this would be the proper graph for number 2 that we have right here. All right, so now on number 3 and number 4, you're actually going to be given a graph and you're going to be asked to describe the inequality. Well, first things first, and we just finished this, so it should be fresh in your mind. What kind of inequality has it is only limited between two different quantities like this? Well, we know from the previous example that that is an and inequality, right? So let's think about what we have here. We could describe this as, let's start with this point and go this way. We have x that is greater than, not including, right, because it's an open circle, greater than -2. But we also have an x that is less than a +3. But again, it only goes to this point, okay? So really our x values, let's think about what this is really saying. Our x values are between -2 and +3. Well, that kind of makes sense with the notation that we saw up here, right? Really what this was saying was x is between 0 and 3. And that makes sense because x is anywhere in here between 0 and 3. And so with this particular example that we're given here now, we could write that one in the same notation. Now remember what we did with and inequalities. We actually started with something that was the opposite of this. So I could put my -2 here, my x here. I could switch those around, but what do I have to do? I have to reverse my sign. So now kind of working backwards, if this makes sense, is I have -2 is less than x, and I also have x is less than 3. Do you see how this statement kind of includes both of these? So we could have just left it the way it was, but this is more correct notation for this particular graph that we have. Okay, now let's look at number 4. So for number 4, you notice that I have lines that are extending in both directions infinitely. So now we know that we're talking about an or inequality, okay? Now, if you notice, let's start with this first one. I have a closed circle, and all of my values right now are less than -1. It also includes -1, but they are less than -1. So let's think about how we could write that. We could write that as x is less than, but it's not just less than, it's equal to, because I'm including this closed point. X is less than or equal to -1. I could also say that x is greater than or equal to, right? From here this way, I'm going into greater numbers. So x is greater than or equal to, because I have a closed dot, greater than or equal to 1, right? Because it includes 1, but it could also include 2, 3, 4, 5, right on down the line. So these are my two statements that make up this graph. We know that in between those would be the word or, because they're going in different directions. All right, so now let's talk about actually solving some problems. And these are really just like two-step inequalities, things that you've already done. But again, you have two of them that you have to work with. So we'll do this real quickly. Again, I'm not going to fool with this portion here. I'm going to do my addition or subtraction first. So I'm going to subtract 2 from both sides, which is going to give me 3r less than 3. And so I would just divide by the 3, which would give me r is less than 1 for one of my answers. Now I'm going to have to do this one as well. So I've got 7r minus 10 is greater than 60. I'm going to add 10 to both sides, which is going to give me 7r is greater than 70. Okay, because this is going to cancel. Those are going to add together. And I'm going to divide by 7. So I end up with r is greater than 10. So there would be my two answers, okay? A lot of these are going to have two answers because you're dealing with compound inequalities. It'll either be two answers like this if it's an or inequality, or it will have the statement like we had right here for a compound inequality if it's an and inequality, okay? So now let's go down. Let's finish the last one, number 6. So again, we're going to look at this as two separate equations, or inequalities. So the first thing I'm going to do, cover up this part, this right-hand part, and I'm only going to focus on this to start with. So I really have 3 is less than 2p minus 3. And then I'm going to do the similar thing. I'm going to cover up the left-hand side, and I'm just going to worry about the right-hand side. So I have 2p minus 3 less than or equal to 12. So again, we would just work through each of those problems. We'll do that real quick. So I'm going to add 3 to both sides. So this is going to cancel. I'm going to end up with 6 is greater than 2p. If I divide by 2 on both sides, I'm going to get 3 is less than p. And we'll leave it like that for right now. I think it'll actually work out good if we do that. If we were going to graph, we would switch that around so that we would know which way to graph. Some of these questions actually graph, some of them don't. The next one in particular, I'm going to add 3 to both sides. That's going to cancel. So I'm left with 2p is less than or equal to 15. 15 divided by 2. I could actually just leave that like that if I wanted to. When you get to Algebra 2, we will just leave them in improper fractions. That is also the same thing as p is less than 7.5, if you really wanted to get real technical about it. Okay, so we would have those two answers. And again, we could put those into our new format that we just learned. So 3 less than p is less than 7.5. So the way we really read that is p is between 3 and 7.5. Okay, so that is your answer for number 6 that we just worked out. Hopefully this has been helpful to you. Again, if you have any questions or concerns, feel free to reach out to us. There are some problems on here that are select all. So you have to be really careful, make sure that you select all the ones that would be applicable answers to the question, okay? So again, let us know if you have any questions or concerns. We'd be glad to help.